pairs of sides and angles. So I'm going to say all corresponding sides and angles to save some space. Are congruent. Then we know that the triangles are congruent. So think back to last semester. We talked about converse. Could you please talk to the person next to you? What's the converse of that statement that we just did right there? Okay, what would be the converse of that statement? Make me real proud if you remember what the converse is. Sophia, go ahead.
If the triangles are congruent, then the corresponding sides and angles are congruent?
Yes. Flip the statement. So switch the order, and then you have the converse. If the triangles are congruent, then the corresponding pieces are congruent. And I'm going to use the congruent symbol instead because I'm out of room. So your converse again is, and please get this down, if the triangles are congruent, then the corresponding sides and angles are congruent. So this leads us to the new, it's not even a theorem, the new thing we're talking about today, which is CPCTC. You may have seen it on your gold sheet already prior to today. It's in that triangle theorem section. It stands for corresponding parts of congruent triangles are congruent. The abbreviation, which I would use if I were you, is CPCTC. Corresponding parts of congruent triangles are congruent. What must you know before using it? You have to know that the triangles are congruent before you tell me that the parts of the triangles are congruent. So you first have to prove the triangle's congruent. When you have this, you can go ahead and switch to your filling in your gold sheet. I would say these two things, corresponding parts of congruent triangles are congruent. You for sure need to have that down because that's just what does the acronym mean. And then what do you have to know? You have to prove that the triangles are congruent first, and then you can use that theorem. Go ahead and write in your givens and mark them in your diagram. Do that now. AB is parallel to DC. DB is perpendicular to AD. And DB is also perpendicular to BC. Those are your givens from the top. And I would mark those in my diagram parallel. You mark with like a little arrow. I'm going to go ahead and mark this perpendicular stuff too. So because I know they're perpendicular, that would tell me that there's right angles there, which I'm going to go ahead and draw in for DB and AD. And, excuse me, there we go, DB and BC. So next statement is that angles ADB and CBD are right angles. Alex, what is it that allows us to say that they're right angles? Yep. Definition of perpendicular. And then the next line down, the reason is all right angles are congruent. So we've done several proofs like this now. Reese, what am I going to put in the statement section? I know that I have right angles because of the definition of perpendicular. What can I do with those right angles now? Someone help them out? Aubrey? You can say they're equal to 90. I would say there's probably a faster way. Tori, what should we say? Right. So Reese, what should we say? Yeah, because they're right angles and all right angles are congruent. That's that right angle congruence theorem, which we don't have written out for us there, but we have the definition of it. Okay, and then the next line is a different set of angles. You have ABD is congruent to CDB. Brennan, what's the reason for that one? So it's a different set of angles. Why are those two congruent? Right. So I'm going to mark that as well. Remember, it's always, you want to mark your diagram as you go. That way, whenever you get done with, you have like 3 either sides, angles, something like that, you can easily determine which theorem it's going to be. Okay, so alternate interior angles. Then we've got a reflexive side. Bonnie? Yep. Because reflexive. Go ahead and mark that as well. So remember, parallel markings are not congruent markings. So that red arrow does not mean it's congruent. The only congruent side we have is DB. So we can say the triangles are congruent. Olivia, which theorem is that going to be? Which theorem am I going to use to prove the triangle is congruent? You have the 2 angles and the side in between. And now, this is where, because we're actually trying to prove that AD is congruent to CB, now that you have proved that these 2 triangles are congruent, I'll highlight them, we can say that their corresponding parts are congruent, which was the whole thing you're trying to prove in this proof. So if you are not sure what to do, always double check, what am I trying to prove and which 2 triangles are those a part of? AD is congruent to CB because corresponding parts of congruent triangles are congruent. CPCTC. We have one more proof. This one should be shorter. Okay, you're gonna have to write in your statement and reasons columns, because I did not give them to you. And please go ahead and write down your givens and make sure they're marked in your diagram. Let's write down our givens. And I'm just going to draw an arrow today. Okay, so we know that we have point E bisects, so point E bisects BD, which means that it's cutting it into two congruent parts. So we can also say that these two pieces that I'm marking right now, BE is congruent to DE. And that is because the definition of a bisector, a segment bisector. Okay, so now we can say that the two triangles are congruent. Triangle AEB is congruent to triangle CED, and that's because of side, side, side. But ultimately, we're trying to prove that AEB, the angles, and CED, the angles, are congruent. So angle AEB is now congruent to angle CED because of CPCTC. Because the triangles are congruent, the corresponding parts are congruent, and so these two angles are congruent because they are corresponding and the triangles are congruent.